So we're back on the page we left off. I'm going to scroll down to exercise 2. In this page, like many of our pages, we have these lovely little question mark things going on. So just to kind of clarify, this should be a theta. Okay, so tangent theta equals 5, 6. Find sine theta and cosine theta. So all these little question marks are really just thetas that moved over. So also we have an angle theta in standard position terminates in the second quadrant. So this is our kind of new information. We did questions like this before. Okay, if the tangent of theta is 5, 6, find sine theta and cosine theta. Well, we would draw a nice little triangle, right? Okay, we would label theta. We would say that opposite is 5. And this is actually negative 5, 6. That just didn't copy through. And the adjacent is 6. But what would we do with this negative sign, right? That really wouldn't have made sense before. So now we're working on something slightly different because we have to think about those quadrants. So let me just erase this triangle. In our directions, it says a picture is always really helpful. And it really is because it's so easy to forget those negative signs or how the quadrant values impact the problem. So anytime I see an angle in standard position, I'm going to draw an angle in standard position. I'm not super concerned about getting it to be perfectly where this should be, but I do get it in the correct quadrant always. So here's my angle in standard position in the second quadrant. From there, I always draw a reference triangle and label my reference angle. And now from here, here's my nice little triangle. I can put the sides on. So tangent is opposite over adjacent. I just have to figure out where this negative sign goes and just use kind of common sense for that. So my opposite is 5, my adjacent is 6 in this picture, and because I'm in quadrant 2, I see that my 6 needs the negative sign, right, because the x value is negative. So from here, everything is pretty much the same. I'm going to use the Pythagorean theorem to find my hypotenuse. So 5 squared, I'm just going to put an h on here, plus negative 6 squared, make sure that's in parentheses, equals h squared. So if I go through this gives me 61 equals h squared. If you got something else, like a negative number, you probably didn't put your negative 6 in parentheses. And then we'll take a square root. So this gives me the h value is radical 61. So I will put that on so we can see it. So my two values that I need to find are sine theta and cosine theta. And this is going to be a little tricky space-wise, but I'm just going to kind of write them in and then we'll move the page over. So for sine theta, I have 5 over radical 61 opposite over hypotenuse. And for cosine, I have negative 6 over radical 61. So to rationalize the denominator in each of these fractions, I'm just going to multiply by radical 61 over radical 61. And that's going to give me 5 radical 61 over 61. And here, make sure you keep your negative sign, negative 6 radical 61 over 61. So here are my final answers. Not super pretty, but that's what they are. And if I think about it, I'm in quadrant 2. That's AS. So I expect just sine to be positive. And that's true. Sine is positive. Cosine is negative. And if I look at the beginning, tangent was also negative. So we're going to do one more of these with decimals, and then I'm going to show the work for the last one. Okay, so I kind of added in the thetas where they belong. An angle theta in standard position terminates in the fourth quadrant. So before even reading any info, here's my angle in standard position. It's terminating in the fourth quadrant. We know that even though this is theta out here, we're using this as the reference angle down here to solve the problem. So it says the cosine of theta is 0.92. So I'm going to put that over 1, and I'll use that as my sides. So the adjacent side should be 0.92 to this angle, and then the hypotenuse should be 1. And just a note here, this is not the unit circle. So when we had answers like this was radical 61 for the hypotenuse, that's fine. Okay, it's not, we're not talking about the unit circle. So we'll do Pythagorean theorem. To find this side, I'm going to label it y just because, you know, that is the y value on the picture. So we have 0.92 squared plus y squared equals 1 squared. And working through that, that's 0.8464 plus y squared equals 1. And then we'll subtract over the 0.8464, giving me 0.1536 square roots. And I should be getting about 0.39, but in my calculator, I'm keeping that whole decimal. Now, remember, when we take a square root, this is really plus or minus 0.39, okay? Now, before, didn't make any sense to have a negative, so we kind of ignored it. Now, when I go over to my picture, I see that y actually is negative, so I'm going to label this with the negative value of 0.39. So we're actually throwing out the positive value. So now I just need to find cosecant of theta. I know that's the reciprocal of sine, so I do hypotenuse over opposite. So my cosecant of theta, my hypotenuse is 1, my opposite is negative 0.39. I want to type that in to get the nearest hundredth. This is the first one we've done with decimals. So keeping this whole decimal, remember if you typed it in from the beginning, okay, from the square root of 0.1536, that should come out to 2.55 here, and that's a negative 2.55. Basically because from the picture we can see it, but also if we're in quadrant 4, the only thing we should get that's positive is cosine and secant. So cosecant, which goes with sine, should be negative. So I'm going to put up work for the last one. So looking at the problems here, I drew the picture. I used adjacent over opposite for cotangent. So here's the black line is my angle. Here is my reference angle. So here's my adjacent side and my opposite. I put the negative down with the opposite side because y is negative in the fourth quadrant. Pythagorean theorem gave me 3 for my hypotenuse. And then from there, I found the tangent value. I circled this showing that if I was starting from tangent to label my picture, I would want to use this answer. It's a little simpler than my rationalized denominator answer, which is over here. Okay. From the picture, this is the sine value and cosecant's the reciprocal, and this is the cosine value, secant is the reciprocal. Noticing that only cosine and secant are positive in the fourth quadrant. So on this page, we have a couple of variations of what we just did. One is where they give me a point on the terminal side of the angle. So we're going to draw this picture out. So my angle, we can tell from a negative sign, falls in the third quadrant. So I just draw it here. It doesn't have to be perfect. Here's my reference triangle, and I put this point out here because that's the information they gave me. So that point is negative 12. Negative 35. I use those values to label my triangle. So this means my x is negative 12 and my y is negative 35. Okay, I'm going to find my hypotenuse so I can answer the questions. So using Pythagorean theorem, and I'll just do this kind of quickly. These two add up to 1,369, and if I take a square root, this is actually a Pythagorean triple for this triangle, and that's 37. Remember, the hypotenuse is always positive, just a rule, so that's a 37. So if I want to find the cosine of theta, here's my angle, adjacent over hypotenuse is negative 12 over 37. The cotangent of theta, reciprocal of tangent, so it's adjacent over opposite. So my adjacent is negative 12. My opposite is negative 35, and those negatives will cancel. And I'll have 12 over 35 going with the fact that cotangent and tangent are positive in the third quadrant. So I'm going to pause the video and then show the work for the next one. Okay, so in this problem, I have my picture, right? Negative 5 is my x and 1 is my y. Notice this is not really to scale at all, and that's totally fine. Like, it doesn't really matter if your sides look the same as long as they're in the correct quadrant. Pythagorean theorem gave me radical 26 for my hypotenuse. From there, I found my sine and cosecant values over here. They're both positive, which goes along with the fact that in quadrant 2, sine should be positive along with cosecant. Noticing my cosine and secant values as well as my tangent values are negative. I had some rationalizing denominators, but I've explained that a bunch, so you can look back at old videos if you have questions on that or ask a question in the comments. So now we're moving down to our third variation of these problems in our lesson. It says a circle centered at the origin has a radius of 10 units. So this is not the unit circle. It's kind of in the same place as the unit circle, but it has a much bigger radius. So here's my circle centered at the origin. Not pretty, but you get the idea, radius of 10 units. The terminal side of an angle, theta, intercepts the circle in quadrant 4. So here's my angle in standard position. It intersects the circle at point B. So the x-coordinate of B is 5.5. I do not know the y-coordinate, so I'm just going to put a y. So let's fill in our information. We know we draw a reference triangle. Our x value is 5.5. I don't know my y value, and the question is, well, if I don't know my y, I need to know the hypotenuse. But luckily we have that because the radius of the circle, like on the unit circle, even though this isn't the unit circle, corresponds with that hypotenuse. So this is a 10. So with Pythagorean theorem, and everything's decimals here, so we can just type it in our calculator, we have 5.5 squared plus y squared equals 10 squared. We have to be careful too, right? Because we know we need to get a negative number for y because we're in the fourth quadrant. So going through this and getting the rest of the picture, we have, this is going to be 30.25 plus y squared equals 100. When I subtract my 30.25, I get 69.75. Take a square root, and keeping this whole decimal in our calculator, we get 8.35. In my picture, though, I have to make sure I use negative 8.35 because my y value is negative, right, going down in the fourth quadrant. So in this one, we just have to find the sine of theta. So sine of theta is opposite, right? So here's our theta. The opposite side is negative 8.35, keeping the whole decimal. Over the hypotenuse is 10 in that picture. So if I type that in, we would just get negative 0.835, right? Moving the decimal over 1. Nearest thousandth, so that's taken care of. Why don't you pause the video, and I'm going to do exercise 8. Try it on your own, and you can come back and check. So on this problem, I set up my picture. I used the 13 as the hypotenuse from the radius of the circle. The y-coordinate is negative 12, so I put that right here. I used Pythagorean theorem to find that the third missing side, which is x, is 5, and I used negative 5 because x is negative in the third quadrant. This is also a triple, so if you knew of 5, 12, 13 triangles, you can use that as well. So from there, my tangent of theta is negative 12 over negative 5, which is 12 over 5, not 12 over 15. And then secant theta is 13 over negative 5, right? That's just from hypotenuse over adjacent because we're always using that angle.